Okay, thank you very much, Alejandro. Thank you to the organisers for inviting me to speak today, and thank you all for joining the presentation, and some really tough acts to follow, so hopefully I'll try and live up to that. And following on from the comedy references from Rachel, now for something completely different. So in my talk, as Alejandro said, I'll be talking about more using plants and particularly straw bales to create a more sustainable built environment. So here in this my first slide here, this is a straw bale building in the city of Bath. It's a school building. It's the Hayesfield School building, the science block. And the building is insulated and built using straw bales. Now, for many of us, straw bales may be, sorry, there we go, changing the slide. Straw bales, think of this material that sits in a farmer's field in sort of July, August after harvesting of cereal crops such as wheat. And there are opportunities really for using this material more sustainably in construction, and I want to explore that. But first, a little bit of context. Worldwide, housing is in real crisis. Around 1.5 billion people worldwide don't have access to adequate housing, and housing in many cities around the world is now affordable to many, many people. Our own government in the UK has an aim to build 300,000 new homes a year to meet current demands alone, and is falling short of that. And to meet those demands and at current rates of resource consumption, we are using around 1 3/4 of the planet Earth's resources. So clearly our approaches are not sustainable, and we need more sustainable solutions to meet this housing crisis. Performance of existing housing, the housing we have at the moment, is inadequate. The energy performance is not in line with our own targets to be a net zero economy by 2050. So not only do we need new housing, but we also need a program of refurbishment of our existing houses as well. The materials that we use to build our houses are not sustainable. They come in the main, they come from non-renewable resources. They require high levels of energy to process them, and in that process they pollute the planet, they add to global warming, and they're not compatible with a more circular economy that we'll need to transition to be more sustainable and meet that target of being net zero carbon by 2050. And in some cases, materials are unhealthy for the buildings and the builders who have to build them, and even in some cases unhealthy for the occupants of the buildings as well. But to give you one context, cement, a wonderful material and a key ingredient of concrete, and concrete, interestingly, is the second most used material by humans on the planet after water, is responsible for about 8% of our industrial carbon dioxide emissions. We've also seen, at the same time as we try to reduce the energy consumption of our buildings, making buildings more energy efficient, that we have built up, or starting to build up, a bit of a health crisis in our buildings. To reduce the energy use, we've made buildings more airtight, and that's quite right, to reduce uncontrolled heat losses. But at the same time, without adequate air ventilation rates, we're seeing build up of pollutants in buildings, which can lead to health and well-being issues, exacerbating conditions such as asthma and persistent headaches. And we've also seen in the current situation the need for good ventilation in our buildings through the COVID crisis to get fresh air into our buildings as well. So in recent years also, I think we're seeing trust, and in recent months indeed, we're seeing trust in the UK construction industry reducing as well. Recently, we've seen companies that have allegedly falsified test results to ensure that their products are used in projects. So I'm advocating a move away from some non-renewable resources, more towards using bio-based building materials, and in particularly plant-based building materials in construction, and in particular the use of straw, but also other materials such as hemp, flax, bamboo, and of course timber and wood-based products as well. Unless you come from a farming background, or maybe you have horses, then most likely you may have seen straw bales such as these in a field, or maybe at country fairs, at music festivals on the side of racing tracks. But the the UK produces around 8 million tons of straw, and it has wide use. It's a co-product of cereal growth. It's part of the food chain, but it's mainly used now as animal bedding material and in some horticultural uses as well. And there are a variety of different straws around the world, coming from different cereal crops such as wheat, barley, oats, and in some countries rice, of course. Straw bales have been used in construction since the late 19th century. Thriving communities of settlers in Nebraska, USA, when the first baling machines arrived, realized that they could form warm homes by baling the straw that was left over from their cereal production. And now some of the oldest buildings in the world, straw bale buildings, are over 100 years old, such as this next slide here. This is a straw bale building just outside Paris, which will be celebrating its 100th anniversary next year. But of course, straw has been used in construction for much longer, for millennia. There are biblical references to straw in mud bricks, and we've used thatch roofs, and it's used for substrate for plasters and as additives in numerous other materials. And pieces of straw have been found by archaeologists in mud bricks that are thousands of years old. So the pieces of straw are still there. They haven't decayed away. Sorry, I'm moving slide prematurely. Rectangular bales formed from compaction can be readily stacked to form walls, as shown here in this single rise load bearing straw bale project. So you can see the individual bales there, rectangular bales rather than those large round ones I showed you in the field earlier, are stacked like large building bricks, dry formed to form load bearing walls. So in that sense, they're supporting the roof structure of this building. And the straw bales provide excellent insulation value, as the farmers in Nebraska knew. And we've seen a move and adoption and interest in straw bale construction in the last sort of 20 or so years, including a move to using it in modern prefabricated construction. So this is a process whereby the walls that form the building are pre-made off-site and then delivered on site to facilitate the construction of the house very quickly. So we have factory-made products which also raise the quality of construction. And it's possible to form 2- or 3-story houses in such a process. In fact, houses can be built within the envelope of the building can be completed within 1 day. And here's a sort of example of construction of a simple prefabricated panel using a structural timber frame and the straw bale being inserted there. And then the panels are completed with a lime plaster, like so in this particular case, but they can be finished in other ways. And then when delivered to site, can form the construction. And this is a prototype building, can be used to build the building very, very quickly. Now, the benefits of using straw, well, straw is a co-product of food production. So unlike some other plant-based or crop-based materials, it doesn't displace land required for food production. It's part of the food chain. And as a raw material, it's also very cheap as compared with other construction materials. Sorry. It's also a very, as a plant-based material, it's a very efficient natural store for atmospheric carbon dioxide. So through photosynthesis, the plants absorb, use carbon dioxide from the atmosphere to form the plant-based material. And it remains fixed there until the straw breaks down. So half the annual yield of straw in the UK will be enough to offset the annual carbon emissions of around 350,000 households in the UK. And that's without considering the energy savings of the new well-insulated straw bale buildings. Straw is obviously renewable, at least annually, in many cases more frequently than that. You can have more than one crop in a year. And they reduce the reliance on non-renewable construction materials and displace carbon emissions. They have excellent thermal insulation values, and a single bale thick wall will meet the most stringent requirements of modern building regulations. They're very suitable for self-build and have been empowering individuals and communities to use it as a form of self-build construction. And just looking around the world, it's very noticeable that straw bale construction movements are often led by women who are challenging the status quo of a largely male-dominated construction industry. So some perceptions of straw bale, just reflect on those. I'm sure at the mention of straw bale, you may well think of the story of the three little pigs, which often comes up. The story in which the big bad wolf huffs and puffs and blows the straw house down. This story continues to reinforce the view that straw bale construction is not very resilient. But the truth is very different. People consider that straw is a significant fire risk, and indeed thatch roofs are vulnerable to fire, as we've seen in the Great Fire of London, and indeed stacks of hay, which are often wrongly confused with being with straw, have been known to combust as they compost. But straw bale walls have been shown to be remarkably fire resistant, and we've completed fire resistant tests and demonstrated straw bale walls to have better fire resistance than many other forms of construction, far exceeding the minimum requirements for the wall construction. Another area is people feel straw, and along with other plant-based building materials, are not durable, that surely they'll rot. But many other building materials, such as mainstream building materials such as gypsum, plasterboard, wood-based products and insulation materials are also vulnerable to decay if they're not used correctly. So we have demonstrated in tests, and I think the history demonstrates, that straw is very durable if used correctly, designed correctly and built correctly. And so I'm quite confident we can build straw bale walls like other timber-based buildings that could last hundreds of years. Detractors also point to rats and mice found on farms as being a problem with straw bale buildings, but it's quite easy to design these issues out, even though the truth may be that we're never more than a few meters away from a rat. These attitudes to straw bale are hard to change, but we're slowly doing this through research and through working with industry and seeing an expansion in the use of straw bale building. So I think the way forward is through research, through experience, and through knowledge. So this is a prototype building called the Bale House, which was built on University of Bath campus 9 years ago now, and has now been taken over and is being used as office space by the University of Bath accommodation services. And we've been continuing to monitor its performance over these years. The sort of product development that we've been involved in recent years include these prefabricated panels, but also development of compressed straw board products and novel forms of straw bale insulation. I mean, at the moment, straw bales are made for the convenience of agriculture, but we could actually start to form them for the convenience of the construction industry by making them of different sizes, and by reorientating the compaction process, we can improve the thermal insulation value by at least 30%. But to see a move of straw bale construction into more mainstream construction, I feel needs support from government to address some of these challenges. And we've seen a far greater uptake of straw bale construction in France, where promotion of bio-based construction materials has been supported publicly by their government. And I think a similar move here would support and see tackling of sort of many vested interests that in some ways prevent straw bale construction from expanding. Straw bale and other bio-based materials can provide healthy housing for the future without causing significant harm to the planet, as demonstrated in my last slide here, which is the Lilac housing scheme in Leeds, which is followed on from the prototype of the Bale house to use prefabricated panels to form this co-housing scheme in Leeds. So thank you for your attention, and I'm happy to answer any questions later on. Thank you very much.